Alright, so continuing our notes, we have one more thing. This is the more complicated thing, is finding summations when we don't know specific parts. So, the first thing is it's much more complicated when we don't know n. So the first thing we need to do is find the number of terms. So in order to do that, we have to recall that an equals a1 times r to the power n minus 1. And it's based on the series we fill out information we know. So this example over here, I know a1 is 49. I could probably figure out if there's an r. Well, again, ask yourself, is it geometric? So how do I get to the next one? Do I add something? Looks like I'm subtracting if I am. Well, 47 to 7, I could divide by 7. 7, divide by 7 again. And it looks like that's my pattern. So dividing by 7 really means that r is 1/7. So r equals 1 over 7. Well, now, based on this, I have to figure out what else I know. Well, do I know an, the value of the last term? I do. An is 1 over 49. So let's use that formula. An equals a1 r to the n minus 1. Well, an is going to be 149. So 1 over 49 equals a1 is 49, r is 1/7. We don't know n minus 1. So we're going to have to solve for that. So first thing, divide by 49. 1 over 49 divided by 49 is going to be a really big number. 1 over 2,401 equals, now we have 1 over 7 raised to the n minus 1. Well, here, this is like the review from last chapter. So, from chapter 11, we need to find a common base, if we can. Typically, you can, otherwise you have to use logarithms. Well, common base, what can we use? Maybe 7. Well, is 2041 to some power 7? Let's find out. Take 2,401, divide by 7, divide by 7, divide by 7. Oh, look, we made it to 7. So it looks like it was 7 to what power? 7 to the 4th power? It is. So I can do 1 over 7 raised to the 4th power equals 1 over 7 raised to the n minus 1. Since I found a common base, now I can get rid of those and set my exponents equal. 4 equals n minus 1. Add 1, n equals 5. Well, now I know all the parts I need to go ahead and find this series. Well, we had a finite series here. So what was that formula? Let's recall it from the last page. The sum of the terms equals a1 times 1 minus r to the n all over 1 minus r. So fill in what we know. We know n equals 5. We know a1 is 49. 1 minus, we have 1/7 as our power, raised to the 5th, all over 1 minus 1/7. Again, if we enter this in our calculator, it gets really tricky. So I want to show this to you. Let's do just the top first. 49, 1 minus 1/7, raised to the 5th power, enter. Now divide that by 1 minus 1/7. Remember, fractions always go into parentheses. We get 57.16. But again, since everything was in fractions, let's turn that into a fraction. 2,801 over 49. And that is the sum of that series. Alright, I'm going to do one more with you, and then you're going to try it on your own. So first, ask myself, what kind of series is this? How do I get to the next term? So it looks like 3 to negative 6, I could try multiplying by 2. Multiply by 2, multiply by 2, but notice that it's alternating. So that means I need a negative. So r actually equals negative 2. A1 is 3. Do I know how many terms there are in here? No, I don't. So, I need to figure out what AN is. Well, that's negative 1,536. Well, now we have to use our formula. AN equals A1R to the n minus 1, and fill in what we know. We know the last term is negative 1,536. First term is 3. Negative 2 raised to the power n minus 1. Divide by 3, divide by 3. Get negative 512 equals negative 2 to the n minus 1. So the question is there a common base? So we probably should try 2, since we have 2 there. So 512 divided by 2, divide 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 by 2, and we get back to 2 eventually. So that was 2 to what power? I think 9 times? Yep. So we know negative 2 to the 9th power equals negative 2 to the n minus 1. Again, we have common bases. So 9 equals n minus 1. Add 1 to both sides. We get n equals 10. So now, fill that into our formula. It was the end, so Sn equals A1, 1 minus r to the n, 1 minus r. That is 3, 1 minus negative 2 to the 10th, all over 1 minus negative 2. So be careful again here when you enter that. So start with the top. 3 times 1 minus negative 2 to the 10th. Notice I put the negative in parentheses because it's important that it is negative. 1 minus, again, negative 2. Oops. We get negative 1,023. Add it all together. Alright, so again, go ahead and make sure you try this last one on your own, and then you are all done with notes for this unit.